What is a theoretical probability? Well, let's find out. A theoretical probability of an event occurring can be thought of as the relative frequency of the desired event to the total number of possible outcomes. Now, that might sound like Greek, but a theoretical probability is similar to an experimental probability, except there's no experiment. It's similar in the sense that the probability is the ratio of the number of times the desired outcome occurs divided by the total number of all possible outcomes. For experimental probabilities, it was the number of times the desired outcome occurs divided by the number of trials. So there's a similarity, but there's a difference. Now, the formula for a theoretical probability of an event is equal to the number of desired outcomes divided by the total number of outcomes. Now, just keep this formula in mind. It will make more sense when it's being applied to a practical situation, but just keep that in mind. The theoretical probability of an event is equal to the number of desired outcomes divided by the total number of possible outcomes. So it's essentially the relative frequency of the number of desired outcomes to the total number of outcomes. To understand what a theoretical probability means, it makes sense to look at the idea of a sample space. What's a sample space? It's simply a collection of all possible outcomes of an event or set of events. I don't expect that sentence to just make sense straight away, but let's look at this example. There's a bag and it contains 5 black balls, 3 white balls, and 2 red balls. If the act of picking a ball is defined as an event, just the act of just picking a ball, if I call that an event, then the possible outcomes are picking any of the white balls, any of the black balls, or any of the red balls. So if the event is defined as picking a ball, what are the outcomes of such an event? Well, from this bag anyway, remember the bag has 5 black balls, 3 white balls, and 2 red balls. The possible outcomes of this event are picking this red ball here, I'm going to call that R1, picking this red ball here, R2, picking the black ball, I'll call this B1, call this black ball B2, call this black ball B3, call this black ball B4, B5. By now you're getting a hang of it. So the outcomes of the event of picking a ball, when you pick a ball, you can pick any of these. So there are 10 possible outcomes because there are 10 balls. So you could be picking this white one or this one or that one. So I'm just writing W1 here, but the circle is quite small, so it's hard to see. But this is supposed to be W1. So just making that clear. So we have an event, picking a ball, and it has 10 possible outcomes. And I've shown this in this diagram. Now, this diagram just represents the sample space. It represents all possible outcomes of this event. We have a bag with 10 balls, and you just need to pick a ball, just one ball. There are only 10 possible outcomes. Either you pick any of these 10 balls. There's no other outcome you can get. The outcome of this event is enclosed here in this sample space. Well, this is an illustration of the sample space. All possible outcomes. So you should get that now. I pretty much just explained the meaning of an event when I discussed what a sample space means. But it is important to have a formal definition of an event. So an event is simply a collection of outcomes. We're going to talk about outcomes shortly, but an event is a collection of outcomes. Sometimes events have only one possible outcome. So imagine you have a bag and there's one ball, and I tell you the event is picking a ball. There's only one ball you can pick. So it has only one outcome, picking that single ball. But the example I explained earlier, where we had 10 balls in a bag, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10 balls in a bag. Such an event has more than one outcome, and it's known as a compound event. So events with just one outcome, an event with one outcome is known as a simple event. An event with more than one possible outcome is known as a compound event. So that's just good to know in terms of formality. So here's essentially an illustration of the bag with 10 different balls inside. 5 black, 2 red, 3 white. Well, what's an outcome? I've just been using the word outcome. What does it mean? Well, an outcome of an event is a possible result of an event occurrence. So if an event occurs, one of the possible results is an outcome. In the previous example, where we had a bag with 10 balls, here you see 10 balls, two red balls, 5 black ones, and 3 white ones. There are 10 possible outcomes. Outcome 1, picking a black ball, B1. Outcome 2, picking B2. Outcome 3, picking a black ball, B3. And so on, B4, B5. Outcome 6, W1, so picking this white ball. Outcome 7, picking the second white ball, W2. Outcome 8, picking the third white ball. Outcome 9, picking the first red ball, R1. And outcome 10, picking the second red ball, R2. I'll just quickly label the black balls. 1, 2, 3, 4, 5. So this is B1, B2, B3, B4, B5. R1, R2, W1, W2, W3, where W represents white, R represents red, and B represents black. So as you can see, there are 10 outcomes. So this is the event. So let me put it this way. The event, defined as picking a ball, has 10 possible outcomes. And I've put them in a tabular form here, and you can also sort of see them here in this diagram. So we've spoken about a sample space, all possible outcomes of an event. We've spoken about an event, which is simply an occurrence with an outcome. And we've spoken about an outcome, which is just the possible result of an event occurring. By now, you should be getting the idea. You should have a good understanding of what a sample space is, what an event is, and what an outcome of an event is. So the first event, event B, choosing a black ball. You want to know the theoretical probability of choosing a black ball. Well, that probability is given by the number of desired outcomes divided by the total number of outcomes. So the desired outcome is to choose a black ball. How many desired outcomes are there? How many black balls are there? In how many ways can you choose a black ball? 5 ways, because there are 5 black balls. So the number of desired outcomes, 5, divided by the total number of outcomes. Now the sample space has 10 possible outcomes because there are 10 different balls. So the probability of choosing a black ball is 5 over 10, which is the same thing as 1 over 2, which is the same thing as 0.5. Clearly this is a linear scale probability. If you wanted to convert it to a percentage scale probability, all you have to do is multiply by 100 and append a percentage symbol. 0.5 times 100 is 50, so it's 50%. Next case, choosing a white ball. Probability of choosing a white ball. That's equal to the number of desired outcomes, the number of white balls, or the number of ways of choosing white balls, which is 3. There are 3 white balls, as you can see, divided by the total number of outcomes. There are 10 outcomes in total. So it's 3 over 10, which is 0.3, which if you convert to percentage, you can try this at home, gives 30%. You multiply 0.3 by 100 and you append a percentage symbol. And finally, the probability of choosing a red ball. Probability of choosing a red ball is given by the number of desired outcomes. So the number of red balls, or the number of ways of choosing a red ball, which is 2, divided by the total number of outcomes, which is 10. 2 over 10 is 1 over 5, which is 0.2, which as a percentage is 20%. So 0.2 or 20%, 0.3 or 30%, 0.5 or 50%. The linear scale probabilities and the percentage scale probabilities are equivalent. So here's an example question. It says, what is the probability of the following simple events? What's a simple event? An event with just one outcome. Following a single toss of a fair 6-sided die. So I'll read that again. What is the probability of the following simple event following a single toss of a fair 6-sided die? What's a die? I mean, if you've played Ludo, you know you have a cube with numbers on each face. You know, a cube has 6 faces, and the cube is such that one face has a single dot, another one has 2 dots, another one has 3 dots, another face will have 4 dots, something like this, another one will have 5, I can't remember how it's done, something like this, and another will have 6 dots. So one face will look like this, sort of, one face will look like this, another face will look like this. So a die is essentially a cube, so it has 6 sides, 6 faces, and each face is labeled essentially with a number from 1 to 6. So what they're saying is, imagine getting that die, tossing it in the air, allowing it to land, and then reading off what you can see. Then asking, what is the probability of getting a 6? So the event getting a 6 has a probability. We need to find that probability. What's the probability of getting a 3? The event getting a 3 is an event with a probability, and we need to find that. And then the third one says getting at most a 4, getting at least a 3. So let's start with the first case. The probability of getting a 6. Well, because it's a simple event, there's only one possible outcome. If you think about it, if I draw a sample space, so I'm just going to draw a sort of four-sided shape. What are the possible events? Getting a 1, getting a 2, getting a 3, getting a 4, getting a 5, getting a 6. And this is just saying, look, if I toss the die and it lands on the floor, what number can I read off from the face that is just essentially directly below my eyes? 1, 2, 3, 4, 5, or 6, because there are only 6 faces with these numbers, so it's any of these. So this is sample space. These are all possible outcomes of tossing a die. So for the event getting a 6, what's the theoretical probability? We're using theoretical probabilities, by the way, because when actually carrying out an experiment, we just know that with a die, there are only 6 possible outcomes if you toss it. Getting 1, 2, 3, 4, 5, or 6. And we're just using this fact to determine the theoretical probabilities. Now, we know the theoretical probability of getting a 6 is the number of ways of getting a 6. You know, the number of desired outcomes. So the number of ways of getting a 6 divided by the number of all outcomes. So total. How many ways can you get 6? Just one way. So what's the total number of outcomes? 6. 1, 2, 3, 4, 5, 6. There's 6 possible outcomes. So the probability of getting a 6 is 1 over 6. The probability of getting a 3 is the number of ways you can get a 3 when you toss the die, divided by the total number of outcomes. And that is simply the following. The number of ways you can get a 3. There's only one way. There's only one possible way of getting 3. And that's if you toss the die and it lands and you see 3. So that's this. 1. And how many outcomes are there? What are the total number of outcomes? 6. So probability of getting a 3 is also 1 over 6. The third question says, what's the probability of getting at most a 4? So at most a 4 means you get less than or equal to 4. That means the highest number you should get is a 4. You can't get more than 4. In how many ways can you get at most a 4? Well, in other words, in how many ways can you get a number that's less than or equal to 4? Well, there's one way. This is one way. This is another way. This is another way. There are 4 ways. What do I mean? If you toss a die and you get a 1 facing you, that's one way of satisfying this. If you toss the die and you get a 2, that's another way. If you toss the die and you get a 3 and you get a 4, it satisfies getting at most a 4. At most a 4 means 4 is the highest number. Less than or equal to 4, that's what it means. So there are 4 ways, and again, we know the theoretical probability of an event is the number of ways you can get an event divided by the total number of outcomes. There are only 6 possible outcomes in this sample space, so probability is 4 over 6, which is 2 divided by 3. And finally, for question 4, probability of getting at least a 3. At least a 3 means 3 is the smallest number you get. So probability of getting a number that's greater than or equal to 3. And how many ways can you get a number that's greater than or equal to 3? Well, if you get a 3 when you toss the die, that's one way. You get a 4, you get a 5, and you get a 6. So that's 4 ways of getting a number that's at least 3 or greater than or equal to 3. 4 ways divided by the total number of outcomes, which is 6. So 4 over 6 is 2 divided by 3. So that's the result. So the first probability is 1 over 6. You can convert it to a decimal or percentage probability if you want. The other ones are both 2 over 3. This is just a simple case of a theoretical probability.